we have a system of equations, and this can be transformed into a matrix. So I've written the equations here and here, and I just want to show you that they're the same. I'm looking at the first two columns, and I can see that each row is a multiple of 12 for these two columns. There's 12, 24, 12, and negative 36. So I can eliminate accordingly. So what I can do to eliminate 2 and 4, I can do R2 minus 2R1. And here we can do R1 plus R3. Here we can do 3R1 plus R4. And for these set of equations, right here, we can apply the same logic. So R2 minus 2R1, this should actually be here. Okay, and I hope you realize that these two things describe the same thing. They're just in a different format. These just have the coefficients of x1, x2, x3, x4. This coefficient is 1, 2, 2, 0, and negative 1. So I'm going to use this matrix from now on, but I hope you realize that these are connected. So with any systems of equations, you want to isolate one variable, and we can actually do that by looking at these two middle rows. We can add 2 of row 2 to row 3. And this is the resultant matrix. So now x3 is found. If we convert this, we say x3 is equal to negative 3. We can find x4 by adding row 3. Okay, so x4 is found. Negative 1 x4 is equal to 0, so x4 is equal to 0. And you realize here row 4, that's useless because we found x3 and x4 already. This can just be used to double check. And negative 24 is equal to negative 24. We can minus 2R3 from R1. We can't find any constants for x or y because all of these are zeros, so we can't reduce it any further. So now let's convert this coefficient matrix using algebra notation. And here is the solution. So we know that x3 has to be negative 3, x4 has to be 0, and x1's value depends on x2 and vice versa. So let's say if x1 is 1, then x2 must be 2. And 1, 2, negative 3, 0 is a solution to the system of equations. But how do we generalize this? Well, if we want to convert this into a vector, we'll have an x value, an x1 value, an x2 value, an x3 value, and an x4 value. Like so. We know that x3 and x4 are negative 3 and 0 respectively. So let's replace x3 and x4 with negative 3 and 0. While this is technically correct, we want to express the relationship between x1 and x2. So how do we do this? Let's look at the equation x1 plus 2x2 equals 5 again. And let's have x1 in terms of x2. So now let's replace x1 with 5 minus 2x2. Now as we can see, the value of x1 actually depends on x2, and the value of x2 depends on x1, which we want. Instead of writing x2, let's have x2 equal lambda. This gives us 5 minus 2 lambda, lambda negative 3 and 0. Let's separate lambda from the constants. Now here we can express this as two vectors, and this is our answer.